Hey, everybody. Thanks for joining us for an invitation to Learning Engineering. It's wonderful for us to be here. We're honored to be part of the group. As you sort of see on this opening slide, it says, this seminar is part of and put on by members of the IEEE ICICLE community, and we'll talk a little bit more about who we are and what we do and why we're coming together today. But I'll start. My name is Kessler. I'm Associate Director of Learning Sciences and Teaching at MIT Open Learning. For those that are interested, I also co-chair with Amy Parent, who will be co-presenting with me today, the ICICLE Design for Learning SIG, and have been part of the community for quite some time and excited to sort of be here. Amy, I don't know if you want to do a quick introduction, and then Henry, and then we'll jump in.
Sure. Thanks, Aaron. I'm Amy Parent. I am an instructional designer and educational technologist. I have been working in both the traditional sense of instructional design, but also been heavily involved in bridging instructional design with educational technology and educational technology learning systems. So nice to meet you.
Great. Henry.
Good morning. I'm Henry Ryng here from Scottsdale, Arizona. I have a small business in the e-learning space, mostly hitting from the technology side, background in flight simulation. Currently serving on the IEEEs and external liaisons for all the specifications around the e-learning standards. Looking forward. Thank you.
Perfect. So we're going to sort of jump in right away. This is the plan for today, generally speaking. We'll talk a little bit about what learning engineering is, our specific group, the Design for Learning SIG that's putting this on. We'll talk about like the work we've been doing and framing it out in terms of AI systems and their design. We'll have two case studies, one from Amy, one from Henry, and then we'll talk about sort of next steps and it'll open up for Q&A as we get along the way. It's great to see everybody. We're going to start with two things. The first is the definition of learning engineering. This comes from IEEE and the Learning Engineering Toolkit. It says learning engineering is a process and practice that applies learning sciences using human-centered engineering design methodologies and data-informed decision-making to support learners and their development. So we usually like to start these things with a survey to sort of see where people are at in terms of their understanding of learning engineering. So hopefully that'll get opened up. Perfect. That's awesome. So if you don't mind, sort of while we're talking about learning engineering being a repeatable process. So one of the things that I think is really important is we sort of thought about the learning engineering process and this representation as a way for us to think about how do we continue to come back to core practices, processes, approaches that we know work and that are embedded within the sort of learning engineering approach as a whole. And so we think about this as the way that we iteratively design, test, adjust, and improve the conditions for learning. And we'll sort of get a better feel for what that looks like here in just a little bit. But it seems like, a pretty good distribution of folks. Really interesting that only 20% are coming to this from a new perspective, which is really, as we've done more and more of these over time, it's been interesting to see how there's more and more people that have a background or at least an understanding. And it's awesome to see so many familiar faces to the group as well. So that's learning engineering as sort of defined. You can put those results, stop sharing, sorry, and go to there. So I mentioned the process, right? So this is the process diagram that we sort of put up and as part of the Learning Engineering Toolkit chapter. Plug for the book and for the chapter being openly available. It is publicly downloadable, and so you should check that out. But as you think about the process, we sort of start with that central challenge. It is a challenge of learners or learning, and it should be sort of orienting all of the work that we do around that. But it's also important to remember learning is situated. And so all of the things that we need to consider have a context to them, the context of learners, the context of the team members. There's sort of various contexts of budgets, of resources, of all sorts of things that go into what we can and can't do to solve that challenge, right? It's not just like pie in the sky, oh, we can just do whatever. No, there are constraints that we have to think about, that we often think about as context. And all of those things need to inform the design and the development and the instrumentation that we sort of put into place to solve that challenge. And we usually have to go through multiple cycles of work to come up with potential solutions, test those solutions, and start working towards an implementation that allows us to actually collect data in authentic settings to understand what's working and what's not, so that we can then continue to follow up, explore what's worked, explore what hasn't, think about what challenges may still be around and how we might need to address those in the next cycle of the work. And I think it's really important that we sort of mention is, in the chapter we talk about this, you have to finish the cycle. It's not good enough to just say, oh, we did it and it worked, right? Like that's almost never the case in really challenging settings. And so as part of learning engineering, we often, think about this as sort of completing the cycle. So who are we? I mentioned IEEE and ICICLE before, right? So IEEE and ICICLE is the International Consortium for Innovation and Collaboration in Learning Engineering. We're a group of people who come together from a lot of different areas of expertise around learning and computer science and research and practitioner work and teaching, instructional design and program managers and a lot of people from a lot of different areas on this call. And we come together and we talk about this work. If you're interested, I encourage you to sort of check out the resource available. We'll have links to all of this later on in the presentation. And specifically, the group that we're presenting today is part of the ICICLE Design for Learning Special Interest Group. So again, much like the larger organization, we're a subset of people who come together to talk about designing and the sort of aspects of what that looks like. How do we focus on being human-centered? How do we keep the learner in the center of the process? How do we keep the learning experience at the center of the process? And what does it mean to engage in cycles of learning engineering practice along the way? We meet monthly, the last Tuesday of every month. It's seriously probably my favorite meeting of the month. I'm not even like, I know there's a lot of people on this call, but it's the best. It's the best call. No shade to the other SIGs and MIGs and everybody else, but like we just have such a great time. It really is the highlight of my month. So thank you for everybody who comes to those. And if you're interested, you should come check that out. But we do all sorts of work. Things that have come out of the SIG more recently, and shout out to my colleague here at MIT, Lauren Citino. We've been working on the Learning Engineering Evidence and Decision Tracker. It sort of has its birth in the work we've done here at MIT, but her and I have really sort of kicked the tires on that idea within the SIG, and really gotten great feedback from the community about how we can build out this idea. And so that tracker and the work that goes into that is available. There's a link if you're interested in learning more about that. But another thing that's come out of the SIG is the Learning Engineering Case Guide. It's a way for us to start to come together as a community and share our ideas, share the ways in which we think about these pieces. And this all matters for a couple of reasons, right? Because it frames out some of the work that we had been doing before we got to the conversations around AI. And so I promise for those of you that are in the room going, where's the AI, man? We're getting there. So, we as a SIG, maybe about a year and a half ago, really started kicking around the ideas of like, what are the conversations we want to have as an organization around the use of AI and AI systems, both from the standpoint of like what goes into them, how are they designed, how are they built, but also really how are they used? How are we as practitioners in these fields using these tools to do the work that we're trying to accomplish and support the learners and learning that we're trying to support? And so, we were seeing this sort of explosion of conversations around, oh, we're using AI for this and it's being integrated into this system and you should use it for all of these things. And so that sort of drove some of the conversations. And then we saw quote unquote experimentation happening in the wild, but there wasn't a lot of evidence coming out of that experimentation. There's even less data. And so we had a lot of questions around that. And then, with those questions came the idea, well, can we be more transparent? Can we think about the ethical guidelines? And within IEEE, obviously, there's some standards that go along with those ethical guidance. And then overall, a need for grounding, right? So in our work, especially as we were thinking about AI, how do we ground this in research and evidence in practices that we know have worked and continue to work for learners and learning? And so we started to think about like, okay, in learning engineering, we say like, why pull on the learning sciences? Well, we know it centers the learning. It's situated, it's in context. And being practitioners, we needed to pull on this diverse set of approaches to address those challenges. And what we were seeing was that the early AI models weren't really doing that. Like if you really kick the early models, a year and a half ago, really hard, the responses you got sort of made you scratch your head if you've been in the profession for a while and you were like, well, it's not wrong, but the thing it's giving me isn't right either, right? Like it's not a full solution, it's not a fully developed design, it's not a well-structured idea, it's not connected with other known things. And so we started really as a group coming together and asking the community, our SIG, some really important questions. Like we really wanted to say, okay, look, hey, where do you see generative AI impacting your work? Where are the areas where you are like, hey, this is happening, we're using it in these ways, and this is what we should know about it? And we saw some community members step forward in the very early days and give some examples. One was from an instructional design system perspective, both from the like it does the work for you as like its own instructional design in a box, or also the idea of how do we train instructional designers, right? So we saw these two examples of these systems, and we had some people come and show early stages of, hey, in the AI does the work for you, like you have these drop down boxes of approaches and ideas and instructional strategies. Here's how it sort of outputs a design for an ID to then tweak and make better and implement. We saw something similar with lesson planning. We had a group come and share some examples of how they were trying to support teachers, mostly in K-12 settings, to have a lesson planning tool, and how the AI was going to sort of build these lesson plans to the systems that they had, to the standards that they were implementing in those settings, in those states, and what that might look like, and sort of talk around that. And in all of those conversations, we as a community kept coming back to whose voice is prioritized in these systems, in these decisions. You have the AI spitting out these, lesson plans. It's like, is that a lesson plan from the perspective of the teacher? Is that from the perspective of the curriculum director? Like, is it from the school principal in terms of the approaches to the way it will be implemented? Like, there was a lot of questions around whose voice is in that, especially in the lesson thing. And in the ID systems, is it coming from the SME who's thinking about these and the best way to quote unquote teach? Is it coming from learning scientists who have been thinking about how to implement this in situ? All of these things. And then obviously a lot of conversation around, how does the probability of these systems work? Can we switch or change the probability in any meaningful way to get the outcomes that we really wanted? So this was sort of the early stages of the conversations. And the direct result of that was sort of the calling out of the black box problem, right? Like it became crystal clear that not all of the systems at that stage were grounded in really anything, right? Like it was just the best probability, and it wasn't taking into effect whole systems of research or practice or any of these things. And so we started to think like, can we as a community put forward prompts, training approaches, ideas that might support doing this work effectively, and what might that look like? And so we continued that conversation, really thinking about AI systems as continuums. And we listed a couple of the examples that we've talked about in the SIG over the last couple of months. This idea of like, you've got systems that are sort of really geared on the learner side, specifically to interact just with learners. And then you've got systems that scale over to the teacher side and just interact with teachers. And you sort of got everything in the middle, right? So you sort of get these spectrums. Same thing with this idea of like, is learning individual, or is it something that is socially constructed, right? And you've got these systems that sort of bridge and are on a spectrum of giving responses or supports or ideas on that spectrum. Same thing with this idea of like single perspective or multidimensional structures of learning, right? Is it something that is just from one perspective of it is just ACT-R theory of cognition? Or is it this sort of multidimensional where it pulls on a lot of different perspectives that we know from learning and practice and approaches? And you've got the spectrum of one to many. And so the place where we started getting to was, okay, how do we provide enough prompting with these newer models as they get better and better to get the right part of the continuum for the work that you're actually doing, right? Because your work is still situated in that central challenge that is addressing needs for learners in the context you work. And so what can we do to prompt the system to get more outputs that we care deeply about? And how do we provide the right set of knowledge, the inputs to some of these systems to get those learning science practices and the sort of learning engineering approaches in? And then what does it look like to operationalize those ideas? And we started asking the community to come forward and share some of those things. And we've been sort of keeping track of some of the pieces. And I know people are coming to this webinar going, man, I can't wait to hear the prompts. And I hope you share the links to all of these things. And unfortunately, I've got some not great news for the people that are here for those pieces, because the truth of the matter is, much like a lot of other things, it's complicated. But what we are going to do today is hopefully share two cases that demonstrate how the community is sort of thinking around some of these challenges, how they're approaching putting humans in the loop, putting expertise, the human expertise into the practice and approach of the work they're doing. And we'll sort of have a call of action of how we'd love for others in the group in community to get involved and maybe come share some of the concrete examples you all have been working around as well. So with that, I will hand it over to Amy to share a little bit about her case.
Excellent. Thank you, Aaron. Hello, everyone. Thank you. So I am going to share some work that we've been doing at Hungry Leaders in some of the significant ways that applying the learning sciences to the development of an AI leadership performance coach has had a pretty big impact on the what, why, and the how that we are approaching the development of this AI leadership performance coach, which is named Claro. Right? So the first thing in order for us to even understand how to approach this challenge is we had to define the actual learning challenge that we were trying to try to solution for. So ultimately, when we think about coaching, it's one piece of a broader journey, and the bookend of that journey that we were looking to solve for or support individuals in the workplace with was ensuring that their solid skill, formal learning and knowledge was actually going to be able to transfer and be sustained in the workplace, but also be further supported in terms of facilitating that continuous development and that strengthening of their skills over time. So once we really got clear on what that learning challenge was, it also became really apparent where we needed to pull from the learning sciences and learning design. And what you see on the screen are some of the main theoretical foundations and the actual techniques that we are pulling into the creation and development of Claro, the AI learning coach. So we didn't actually start there. Like many ideas, we started with an idea, pressure tested it in the market, seemed like it had legs, and a couple of those perspectives, kind of started leading the charge. But when we really re-anchored ourselves to the learning challenge that we were trying to solve, it actually became much clearer and almost obvious that there were perspectives and stakeholders missing. And so what you see on the screen are who those current contributors and stakeholders and perspectives are today. And we also realized that this was going to be an iterative process. And so the learning engineering process just naturally worked its way into the way that we work and the way we're thinking about how to iterate and continue to evolve the development of this. So I'm going to just focus on the perspective of the learning sciences and how we actually operationalize that in the build of this AI. It's not even just the AI coach itself, but it's a much broader system that is behind it. And like Aaron said, the complexity is not as clear until you get under the hood, right? So there were three places that I'm going to walk you through today where the learning sciences were pulled through. The first place was apparent. We needed to look at how we were shaping the identity of Claro, the AI learning coach, right? And once we understood what we need to do there from a learning sciences perspective, that very quickly translated out into how those conversations had to actually operate. And so that's where we started to see the need for technique and actually what good levers we needed to be sure were happening and applied in those conversations. And then naturally from there, because of the goal of those conversations and the output that came from those conversations, it completely impacted what the learners were going to get of value and how they were going to actually manage that in the spirit of the challenge that we were trying to solve for: continuous learning, self-regulated and self-directed approaches. So let's start with the system prompt, right? So in the beginning, it was one big, massive prompt. You know, we understood we had to tell it who it was and what it was supposed to be doing. And then we threw some branding things in there, like we want this tone and this voice. And when we actually took that for its first test run, it was very typical LLM-driven experience. Claro, the AI system, barely asked you any questions, made 1,000 assumptions, and gave you a laundry list of solutions that'll solve all your problems, right? So that was definitely not what we were after. So when we stood back and we understood, well, hey, look, let's get back to what we understand about coaching, what works in the workplace for adult learners. That was a thing. What actually is needed to support learning to keep people motivated in this process. And that's how we came up with what you see on the screen are the 6 core principles that are behind Claro, the AI Learning Performance Coach. And those core principles had to really be very well defined, and they had to be defined at different levels. So if we move to the next screen, those principles are built into the main system prompt. And to give you a little bit of perspective, the main system prompt is kind of like its main governance structure. So it always takes priority over any other prompts that are underneath of it, which we'll see in a bit. So you have to keep it, we had to keep it high enough level, but we also had to have it be clear and directive. And if you look closely at the information that's in the green, while we didn't go into all the details, we would state what the principle is and then just briefly, quickly, concisely how you operate that principle. What is also behind this is we are using a RAG system approach to give Claro all of the knowledge that it needs to be an effective coach from different domain areas and different perspectives. And one of those perspectives is learning sciences and learning in general. So we do have a separate document that we've built that uncovers each of these principles much more deeper, right? And it's always available to Claro to pull both at the system prompt level and then in other places throughout the system. So that's the first place. So once we've done that, like I said before, we then realized we had to separate things that were in the big prompt about how to run the conversation from how to be a coach, right? Like, what is your identity? And that led us into the world of what we call state machines. We needed to give the conversation some structure. We understand in general that conversations have structure, right? So that opened up a bunch of other questions for the learning sciences perspective. So if we move forward, let's take a look at how that evolved. So on the left side of the screen, before we really had taken that perspective in fully along with the others on the team, including the experienced coach and the behavioral scientist, we put together this first flow, and it was almost like a wish list. And it was a conversation, if you take a look at it, that not only explored and understood, but then it had you practicing, and it had you also making plans, like all in one conversation. So if you can imagine what the experience was initially, it was doing everything we asked it to do, but to the learner, it just felt overwhelming, confusing, and you really didn't really walk away with what we wanted you to walk away that was meaningful. So we stepped back, we rethought it, we looked at the observations that were shared, and we really brought in what we know works in learning and in helping people work through conversations. And if you just look at it, just take a second, you can see the structure is so much more clear. The goal of each part of the conversation is distinct. And you can begin to see how the conversation is leading to some kind of concrete set of outputs. So I'll pause just for a second to point out that each layer of the conversation, coach, goal discovery, goal confirm, those are actually states. And it does run linear, top to bottom, with conditions that also direct whether you stay in a state, you go back, or you move forward. But within each of those states, for example, goal discovery, there is another prompt, right? There's another layer of prompting to the AI system itself. And that is where we have specifics about how to define a goal, what questions you have to ask, when to recognize when you have a strong goal identified with the user, and then how to present that back to the learner in a usable way, right? And so we have that all the way in every single one of these prompts. The reality prompt is really trying to normalize, so we pull on the behavioral sciences there and other domain knowledge that's in the knowledge body that we've been standing up. And then the way forward is really where the main output is for the learner, for them to manage. And that's either micro action that they define, and we try to constrain them to just one or two actions they're going to take first towards the goal, or an implementation intention or an if-then plan that they want to try and habitualize and change a way they respond. So right away, if you hear the words that I'm saying, I'm talking outputs, right? And I'm talking about the outputs for the learner to take forward. So that naturally then forced us into rethinking what is going to be useful to the learner to put back or mirror back to them within the platform. Also making sure that they can manage it for progress and have that agency. That leads us to the next implementation. So you can see it's like pulling you start one place and then you kind of end up dominoing into other parts of the system. And I think that's the main point that I'm trying to make here, and that those learning sciences just become more and more granularly applied depending on where they're being applied in the system. What you're looking at here are two versions of the first dashboards. This is where the learner is intended to come back and see how they're progressing towards their goals, towards their actions, implementing their if-then plans. But the first version of the dashboard was doing something completely different. It was an entirely different goal. It was trying to serve an entirely different purpose. The one that you see on the right is what we have operating today, right? And we're testing. And the learner has full management of it. Everything on there comes from the conversation, but the learner can come here and they can edit it, they can decline it, they can set calendar reminders if it's some action that's timely for them. They can even vote in terms of how confident they feel and leave notes in terms of what they've learned in trying to implement that. So all in all, we started recognizing where we needed to apply the learning sciences and the learning science perspective in the core AI system prompt. But that quickly helped us then realize where we needed to bring in learning sciences as technique in the conversation structure and the interaction, which then generated the kind of meaningful outputs that the learners needed in order to regulate and direct their own learning. So where are we today? Well, it brings us back to the learning engineering process as a whole. Everything is, we are literally iterating live. And one of the things that's interesting about this diagram is it's almost like perhaps a set of galaxies that are layered on underneath of each other. So while it looks like a flat, static, iterative system, there's actually several iterations that do occur. We are in between 1 and 2 now. We are actually running tests with individuals out there who are interested, and we're collecting that data, and we're using the lead inspired method for collecting some of that evidence and logging where we need to make some decisions and what those decisions are grounded in. So if you are interested or you want to learn more about Claro and Hungry Leader, just feel free to reach out. We are in active testing mode. So thank you.
Perfect. Thanks, Amy. Henry, hand it over to you.
All right. Hey, thank you for this opportunity to share. I'm going to go through how we applied and baked in learning engineering into a grant-funded SBIR Phase 1 project. It's designed to benefit at-risk workers, and it's funded by the NIEHS as a product that we're calling HSTCoPilot. Next slide, please. Project goal is to have impact on just-in-time training that's delivered post-disaster as cleanup workers are activated. This is a diverse, underserved population with little lead time. There are resource constraints, and there's a need to adapt to contextual circumstances. So we propose the ability to take an array of pre-existing training materials, references, and guidelines and deliver an AI-assisted human-in-a-loop training generator that's personalized to the target audience and the hazards at hand at their reading level, in their language, and with iconography supporting that. So the R&D was an iterative process. We had a stakeholder review of the plans and the incremental work products as they evolved. Early iterations of the AI prompts baked into the workflow, they showed promise, but we sort of plateaued on advancements as the detailed reviewer feedback came in related to domain areas and health and safety accuracy. So the breakthrough for us was to model a team of AI agents. They needed to act like the learning engineering team, including the SMEs, the subject matter experts. We came up with a JSON model, which is a technical structure for the data. So the AI agents and the humans were speaking the same language, but the humans were shielded from the underlying structure. So the platform ingests the training and the reference materials, and I think Michael mentioned that was a RAG earlier, as well as having access to authoritative subject domain documents. So we extended that with trusted resources. So the agents were modeled to act like an experienced instructional system designer, and we used the MIL standard for instructional systems design to teach it how to act. So by conclusion of the Phase 1 R&D work, the platform ended up with 7 AI agents that were modeled and refined and iterated during the project. They ingest, act on, and produce a JSON file on the previous step. This is a predictable structure handed off to the next team member or the agent or the human intervention in between that. This creates a predictable workflow structure. So the human in a loop has a polished graphical user interface editor to review, edit, while altering or extending the underlying JSON. And on save, it wakes up the team to act on a refined content. So in some steps, editing concurrently or extends or refines the prompt, and I'll tell you a little more about that. So at each step, the human can inspect the work product and tinker with it. So in this example, the SME edits what's wrong with the work product and serves as I guess you guys call it modeling. We found a way for the SME in natural language to elaborate on the general rule, not just the edit needed. So we ask SMEs to state a boundary condition where it can safely apply, include a reworked example, and add a fallback for ambiguity. So this is really the art of prompt engineering and AI. In phase two, we intend to build a wizard that can be purposely built to extract this kind of tuning by asking the right questions of the SME, making that a little easier. This results in a kind of crowdsourcing that enables the continuous enrichment of the platform. So the granular AI agent actions were designed to rationalize their action and record it into an integrated learning engineering evidence and decision, the lead tracker. So that's a shout out to Lauren Titino and Aaron Kessler. Thanks for sharing that pattern. It was a fun experiment to see how these injects into lead from AI agents and how they can work alongside the human input. And we're sure to do more of that in phase two. So the stakeholder reviews led to exemplar samples of output. These agents were refined to consistently do work to produce similar content. A fun fact in that process was that for some steps, we used AI to write code and put AI out of work. So we're able to replace the AI calls for some of the systematic operations. Okay, so the HSTCoPilot has the best practices of learning engineering baked into it. So if you have a use case to support our phase two efforts, please reach out, and thanks for the opportunity to share.
Thanks, Henry. Two great examples. I'll wrap up and then we'll open it up for discussion. I'm sure there's a fair bit of questions, and I know there was some that were coming through in the discussion or in the chat. So where does that sort of put us? Like, if we think about this learning science and learning engineering sort of relation with these AI systems, right? Well, ultimately, learning engineering from our perspective as people who are sort of working in the field is grounded in the learning sciences. Those two things are inseparable, right? We leverage these approaches, these research-based practices and ideas in the work that we do. It's a sort of required. But what it allows us to be is nuanced, right? So what you heard from both Amy and Henry is they're leveraging these pieces in very specific ways to address the challenge that they're confronted with for their learners. It's not one solution for all. It's not a tutor for the whole training facility, right? It is, how do we address this need with this population in these ways? And then it's the inputs inform decisions that are made, right? So then it's then tracking how do those inputs, how do these sort of practices and approaches play out in the decisions we make? Where are those decisions happening? Why are they happening? How do we document that? And how do we keep track of that over time? And then how do we test this? How do we continue to iterate forward? I think with both of these examples, one of the things that we see is that it's not static. And Amy's example of sort of like the stacking galaxies of the nested leaps, I think is a great one, in that it shows that these things are interconnected in ways that we sometimes don't always acknowledge, but that really have a huge impact in the way that they get used, and who uses them and how it's used, and how people maybe want to come back to them. And so, we need to collect data and evidence around those things and continue to move those forward. So what's next for the design SIG, right? Like, we continue to have these conversations, and we want to continue to collect examples and share these cases. We want to ask really critical questions like, what does it mean to engage in leap cycles, that are forward to make LLM-based AI systems have these sort of central human in the loop approaches? What does it mean to expand on Henry's work in other contexts and maybe leverage this as a model of the ways that we can start to force these systems to better engage with us rather than just that black box approach? How can we approach the work in ethical and purposeful ways that sort of have these mindsets baked into them? So much like we're sort of leveraging these baked-in learning engineering approaches, can we bake in ethical practices and ethical approaches to the way in which the systems are used or not used? And then ultimately, can we share what we find? How do we share this out with the community? We're obviously doing it here, and we want to continue to think really hard about what would benefit everyone in sort of being a place to share these things, as we are sort of an open community. So some of that might be your jam. And if it is, I encourage you to come to our SIG meetings and share and be part of it. But sometimes that might not be your jam either, right? And so I just want to acknowledge that within ICICLE as a whole, there are a lot of special interest groups and market interest groups, everything from PK-12, higher ed, workforce, and then government and military. And then other special interest groups, you've got the tools and instrumentation group, the competency, credentials, and curriculum group, students in grad, and localization and globalization. So we will open up a survey right now. So if you are interested in any of these, or the people from the SIG or MIG reaching out to you, if you respond to the ones that you're interested in, we'll get your name and contact information over to the people in charge of those groups, so that you can sort of get connected with them. And while we're collecting that, I'll sort of also just acknowledge our leads for all of those groups. They're really wonderful. It's so great to have worked with these people for so many years, and see how it's sort of developed over time. And all of them are working on really interesting problems. We get to be the voice of this AI conversation, but I know it's happening in other groups as well, and lots of other really great work as well. So there are lots of other resources too. I want to acknowledge really great things that are out there beyond LEAD and sort of the toolkit. If you're interested, you can check out some of those things and some of the resources that exist there. And just a huge thanks to everyone for coming and engaging, and hopefully you are able to join one of these groups moving forward. And we will open it up to sort of some Q&A. And so if people want to unmute themselves and share, or if have questions, I will try to get back to the chat and circle through what's there. But love to hear what people are thinking about and sort of working on and want to talk more about. It was so great. We covered it all. Nailed it. We've solved the AI problem.
I've got a question. Henry, I would love to have you talk a little bit more about how you use the lead tracker to kind of keep the AI systems in check.
Well, as Aaron knows, I'm a big fan of that. So, as a small business, I love the lead tracker because the history of how the project unfolded, it's not confrontational when you say where you change directions or where you've made something that impacts scope. But that's not really the core purpose. That's how I've adapted it. So, but we wanted to expose the thinking of the AI to the agents, so that the subject matter experts had a clue as to how they would, because we were trying to teach them a little bit cryptically how to improve the prompts, not just give us an edit to the work product, how to generalize their feedback, and the AI agent thinking through disclosing how it thought through the challenge and what decisions it made was helpful in that.
That's great. So just so I understand, you had it set up where the AI, the LLM would kind of answer back its rationale for each design choice?
No, under the hood, we had the agents doing the work, but when they concluded the work, they summarized what they had for context and what decisions they made, and recorded that.
I see. Excellent. Were there any instances where you found some errors or some things you didn't want to see, and then you kind of course corrected from there?
Yeah, of course we had to make things technically accurate, so we just created more guardrails and expanded. So sometimes the instructor was able to load up random learning materials. So we went in the front of that and said, is this really health and safety training related? Because somebody just loaded something related to stewardesses or something. It was unrelated, but we can screen that out. So we added a fail check in there, and then just increase the guardrails and increase the sophistication of the agent prompt over time.
That's great. Thank you for sharing that.
Thank you.
And just a quick note, Henry, the question is, did you have instructional designers as SMEs doing the prompting as well?
Um, not directly doing the prompting, but because the nature of the project is it's easier if we don't have an IRB board, so we didn't have human subjects, but we did have senior professionals in the health and safety training field as the SMEs, so they were evaluating the platform as well as critiquing the output, and indirectly we were using their feedback at first. We were intermediaries on translating what they were asking for. But then we had some working sessions where we showed them what we were doing with their feedback, and they were able to adapt how they were providing that feedback and kind of excited about it.
Awesome. Thanks, Henry. And then I think for sort of, Japhis, I don't know if this was if you were sort of hoping to get from either one, but there's questions of like how are anybody implementing chain of reasoning, and how are maybe agentic AI advancing autonomously the transformer model to improve the underlying LLM algorithm. I'll let you both share, and then I don't know if I have a thought on that, but maybe I'll circle back. I don't know if either of you have an answer to either of those.
Think the high level answer I can give you. I'm not an expert in terms of how the back end operations are working. That would be our engineering team that I work very closely with. But we are not at the point where we do have a chain of reasoning built in fully into the back end yet. We do have several different state machines that are running off of the main state machine with the conversation flow. And we are not using agentic AI yet, but we do have plans in the works for bringing in agentic AI as part of the evaluation for the conditions for moving forward, evaluation of sticking with prompt guidelines and governance that we put in place at the system level. So that's my best answer from my perspective.
That's good. And thanks, Henry, for responding in the chat to Jim. One of the things that I think I'll say more broadly, right? It's not specifically answering your question, so I'll front and acknowledge that. But part of what has to be thought about also is the context of which these data structures are happening. So Amy and I think Henry have acknowledged that they're sort of doing this with a very specific set of learners, and they're using sort of data standards around, from IEEE and from other places. But I think what's also important to note is that some of the limitations around what types of AI and agentic agents can be implemented in certain settings is going to be limited by the data and data structures that they can pull on within those systems, right? So when Henry mentions that, sort of the inputs that he's able to sort of have there, a lot of that is because of the nature of those resources, that they're openly available, they're structured in ways that he can quickly ingest. That might not always be the case, especially in K-12 settings, especially in other higher education environments, right? And so just to acknowledge that what you can ingest and whether or not you can use it to train the LLM more broadly is going to be dictated by sets of standards, requirements, sort of all of these pieces. And then that also starts to get at, I think, a little bit of the question that Jim Goodell is asking, which is, are you able to sort of like keep track of these outputs and share them? I think is sort of like separate data sources that then might be ingested in other systems or in other ways. I think becomes really a central question. I don't know if anything I'm saying is making sense, but that was sort of how I read that question. Other things people are running into or thinking about?
Yeah, I'm just replying to Jim's question. I think, and it's actually an interesting tie into what Henry's doing potentially. Like we are generating trace files, which have been invaluable in trying to do troubleshooting and understanding why parts of the conversation are behaving the way that they are. But again, all of that is being hand logged. It's all being hand run and on the back end. So there's a lot of interesting potential to elevate the learning engineering process just within the system itself there, like Henry has demonstrated.
Yeah. Yeah. And I'll note one quick thing and then sort of pose this question. I think it's important for all of us to sort of think about this as not like, can I directly take what Henry did or what Amy did and replicate it? But can I take the overall approach and sort of thoughtfulness in which they're constructing and engaging with some of these systems and maybe mimic or mirror approaches in your own work where this might play out effectively for you. And it might be a different way of thinking about maybe how to get humans in the loop, or maybe how to get, knowledge into the system, or, I don't think anything we've talked about today is like cutting edge approaches to AI system development, but I think it is thoughtful, learning grounded approaches to doing some of this work, which I think gets at what Lisa is asking, which is, is there any concern that we're sort of unintentionally training AIs to brainwash learners toward these goals? Yeah, right. Like if you're not asking those types of questions, I'm not sure you're even starting with the learner in the center to begin with, right? I mean, I would argue we need to be sort of fronting that, like, what are we hoping to achieve out of our learners, and how are we going to collect evidence from their actions that help us understand whether or not we're sending them on the right path, or whether we are diverting towards something that is not what we want. And I know a lot of people in this room, beyond just Amy and Henry, have spent a lot of time thinking very, very deeply about some of those questions and how we collect evidence around that. Catherine, I see you on the call. It's great to see you. I'm looking at you specifically about that sort of learner piece, especially, and many others. Yeah, I think that's sort of some of my thoughts. I don't know, Amy or Henry, I don't know if you have anything additional to say on that front.
Yeah, I think it's a fantastic question. And it's actually a question that we ask ourselves all the time when we start trying to think through problems. And we ask ourselves, what should the AI not be doing? And that's a really important exercise for us to always be exercising. And we also made a very conscious effort to also build in some governance structures, some hard rules, some guardrails into that main system prompt. Some of them, the EU AI Act is also built right into that prompt, and it's transparent and it can be pulled up and read. And the same with some of those additional guardrails that you're asking your question around, Liza.
Yeah, great. Thank you. Jim, I saw your hand come up. Jim, do you want to jump in real quick?
Yeah, real quick. The IEEE Adaptive Instructional Systems work group is doing very much like-minded to what Amy and Henry presented here. The idea of needing multiple roles to look at the different aspects of learning is complex. So having the standard that is being proposed considers the role of a pedagogical agent and a motivational agent and a general learning sciences agent. And they're all, you kind of think of it as a team of specialists that are surrounding the learner. And but some of those specialists are AI agents. And so what the technical standard deals with is the interoperability between those agents. And then it uses some of the other IEEE ADL total learning architecture standards for things like logging with XAPI and such. But very much along the same lines of those multiple roles and multiple specialists.
Yeah, and I'll say one last little piece about that is obviously it deals with the technical piece, and I, I think it's really important that we also remember and are upfront about where. Remember, there's the we were talking about those continuums earlier. So, a pedagogical agent can be on a continuum of sort of beliefs and approaches and structures around what learning even is and the goal of that learning and how you achieve it. And so thinking really critically as we think about the goal and the purpose of each of those agents, and the fact that we might need multiple of those to then enact the thing that we ultimately care about. And so having interoperability is really important, but also having the breadth and the specificity at the same time. The breadth of, like, you've got a lot of options. We can bring a lot of understanding to bear on what might be the best way forward, while also having the specificity to understand the context of the learner, the needs, the sort of stated objectives of supporting those learners in a system. So there's a real balance to be struck there, and none of that is defined yet, right? I mean, I think we're all sort of testing the boundaries of what that might be. And Henry and Amy's work, and many others, I think has sort of pushed us to do this. As Molly noted, I think it's groundbreaking because it does. I'm with you, Molly, right? Like that idea of forcing humans back into the decisions becomes really critical. And there's no way that Lauren and I could have ever imagined that this is where Lead would have ended up with, right? Like, we were doing it because we as humans needed to track these decisions because there's a lot of them and it's hard to remember all of them. And they provide entry points into thinking about this. And it provides a way to communicate human to human. We weren't ever thinking it also was going to potentially provide a way to communicate AI agent to human or human to AI agent. And that's, there's a lot to unpack there too. And so I think these are all really, really interesting areas. I know we're coming up on time, and so I want to thank everyone for coming on the call and sharing your questions and ideas. I want to send the deepest heartfelt thank you to Henry for being willing to jump on this call sort of a little late in the game and share his really awesome work. And then most importantly to Amy, thank you, Amy, for being such a great co-chair and partner in all of the Design for Learning work. Your case and your efforts here are outstanding, and I'm so grateful for everything you've contributed. Thank you. Thanks, everybody. Thank you to the larger ICICLE community for putting this on. We look forward to the other presentations from our other SIGs and MIGs in the coming months. And please reach out if there's anything any of us can do. We are here as a community to engage. So thank you again, everyone, and we look forward to seeing you at the next event.